Chapter 8, Section 3, Solving Right Triangles. So in this video, we're going to review the meaning of sine, cosine, and tangent. We're going to learn how to use the inverse sine, and cosine tangents. We're going to learn how to use the inverse sine, cosine, and tangent functions to solve for angles, and discuss the relationship between slope and angle. I am also going to start talking well right now. I want to just kind of talk about sine and cosine and tangent again really briefly. SOHCAHTOA. Imagine that I told you about two brothers, and I said that one brother was half as tall as the other. You don't actually know how tall either brother is, but you know about the relationship. They could be this size or they could be this size, but the point is one of them is half the size of the other. Now, half is a ratio that we're very used to dealing with. I could have said the ratio is 0.5, but we're very used to a half. But suppose I said that one brother was like 0.347 the height of the other. Well, 0.347 we're not quite as familiar with, but that's pretty close to 0.3 repeating, and 0.3 repeating is a third. So maybe one brother is a third the size of the other. It would take three of these brothers to match their height. If you know the ratio between the two brothers, then all I have to do is say something like the short brother is 2 feet tall, and now we know the tall brother must be 6 feet tall. So once you know the ratios for all of these things, all it takes is one actual measurement to find the other information. That's what sine and cosine and tangent do for us. They give us a ratio of sides. So say that I had a right triangle, where I knew this angle was 34 degrees. If I go to sine, and I find the sine of 34, it used to be back in the old days before calculators, you would look at a table. Here's the angle of 34 degrees. The sine of 34 is 0.5592. That means that if I took the opposite side and divided it by the hypotenuse side, I would get the decimal 0.5592. Well, then let's also say that I know that this length here is 10. Then this hypotenuse over here has to be something such that 10 divided by whatever the hypotenuse is has to be 0.5592. Let's just call that letter C instead of writing hype. And then we'd multiply both sides by C and divide both sides by 0.5592. And from that, we could calculate C. Find the hypotenuse. Whatever it is, it's going to be a little under 20. Sine, cosine, and tangent are just collections of ratios of sides. And before we had calculators, we would look them up in tables. And before we had the tables, we had to go create the tables. But somebody figured, okay, I'll do the sine over, or opposite over hypotenuse of 6 degrees and opposite over hypotenuse of 13 degrees and write them down. Well, here's where this gets really useful. Well, twice as useful. If we can use an angle to find a ratio with sine, we can also use a ratio to find an angle. That is called sine inverse. Okay, so imagine that I had a triangle where I didn't know this angle, but I knew that this was 10 and this was pretty close to, or a little bit under 20. We'll say it's 19. Well, the sine of some angle is going to be 10 over 19. I have to find that angle. I wrote a theta. I'm going to write an x. The sine of some angle x is 10 over 19. I can calculate 10 over 19. Ten over 19 is 0.5263. And look on the table and see, okay, where do I see 0.5263? It's going to be somewhere in here. So my angle is going to be somewhere between 31 and 32 degrees. That would be what we call an inverse sine. That's where I look at the ratio first. I look at the ratio and use it to find an angle. Well, our calculator can do this ratio even more accurately for us. If I'm in my calculator and I press second sine, that gives me sine to the -1. That little -1 up there means I'm doing the inverse. And now I type in the ratio that I have, 10 divided by 19. It's going to spit out the angle, 31.756. I was kind of close, but it's 31.756 degrees. The plain old sine function gives you the ratio. It spits out or it yields a ratio of sides. The sine inverse function spits out or yields an angle once you input a ratio of sides. So now we can use sine, cosine, and tangent to find angles and sides of right triangles depending on what we're looking for. So let's practice. I want to find this angle here. So I know that the tangent of A is opposite over adjacent, which is 10 over 8, which I could reduce to 5 over 4 if I wanted to. I'll keep it 10/8 for now. No, that hurts my head. I'm going to make it 5/4. The tangent of A is 5/4. What I really want, though, is I want to know that the tangent inverse of 5/4, that'll give me angle A. On my calculator, I'm going to do the inverse tangent, second tan of 5/4, 51.3 degrees. Now it would be very easy to find this angle right here, angle B, by just doing 90 minus 51.3. I know this is going to be 38.7. But I want to show you another way I can do this. I could also say, if I want to find angle B, I know that the tangent of B is 8 over 10, which is 4/5. So the tangent inverse of 4/5 is going to give me angle B. 38.7. Okay, on your own, find both these angles. Start with this one. Find that angle first. And it's really nice just to put down the A's, the B's, and the C's if they're not given to you. If I'm going to find angle A first, what I have here is cosine. I'm going to use cosine inverse. The reason I'm using cosine inverse is because this side is the hypotenuse and this side is the adjacent, and that's cosine. Cosine is adjacent over hypotenuse. So I'm going to do the cosine inverse of 7/12. $54.3. Wow, pretty close to the last one. It's 54.3 degrees. Which means that we know that this one over here is 35.7 because these two have to add up to 90. They're complementary. However, let's talk about finding it with sine. I know that the sine of angle B would be 7/12. So the inverse sine of 7/12 gives me angle B. 35.6. 35.68, which is 35.7. Okay. Will you... Is that everything? I feel like I had one more slide I wanted to do. Oh well. Ah, that isn't everything. Here we go. So, if you want to find a side length, use regular sine, cosine, or tangent. But if you want to find an angle measure, use inverse sine, inverse cosine, or inverse tangent. And just so you know, those are also called arc sine, arc cosine, and arctan. That means inverse. Please take a second and solve this triangle. Solve means find all the missing sides and angles. So you should find 2 more angles and 1 more side. Ready, go. Let's start with side B first. I can just Pythag this. There we go. So b equals the square root of 7,500. I'm going to actually do that at my calculator all the way to make sure I'm correct. If I do 100 squared, I get that. I'm going to subtract from that 50 squared, which is correct, okay. I'm going to square root that whole answer. 86.6. Wasn't repeating, just 0.6. Alright, now let's find some angles. I'll do angle A first. If I'm going to do angle A first, then this is the opposite, and this is the hypotenuse. So opposite over hypotenuse is sine. Because I have opposite and hypotenuse, I'm going to use sine. So I will say the sine inverse of 50 over 100 is going to give me angle A. Well, that's actually the sine inverse of a half. I'll just calculate that. 30. This is 30 degrees. So we just learned something pretty important here. If one side of a right triangle is half of the hypotenuse, you know its corresponding angle is 30. That's a nice one to remember. If you have a triangle, a right triangle, where one side is half of the hypotenuse, then we know that this angle right here is 30 degrees. And if that angle's 30, it's pretty simple to find this one over here. It's 60. Okay, what angle does the line y equals 2x plus b make with the x-axis? We're going to graph a line here. Now you might think, wait, we don't know how to graph this line because we don't know what the y-intercept is. They gave us some letter b. It doesn't actually matter. B could be anything. It could be really high or really low. But as we move this line around, the angle it makes isn't going to change. We're checking to see what is this angle right here. And that angle right there isn't going to change as this line moves around. So how do we find it? Well, think about slope. Slope is up 2, right 1. That's the rise over run. So if I go up 2, right 1, and you'll note I didn't even draw this to scale or draw it well or put any labels on this graph or this grid. That might help you. That might be helpful for you to do that. But I can actually just see I've got a right triangle that's going up 2, right 1. I'm trying to find this angle right here. Now, before I can find that angle there, I need to find this angle here. So let's call that angle A. I'm going to find angle A. Here's the opposite and here's the adjacent. So I'm doing tangent. I know that the tangent of angle A is 1 over 2. So angle A is going to be the tangent inverse of 1 over 2. The tangent inverse of a half is 26.6 degrees. If this angle right here was 26.6, then this angle here is 90 minus 26.6. So that's going to be 63.3. Okay, so the angle made with the x-axis of the line y equals 2x plus b, whatever b is, doesn't matter, is going to be 63.3 degrees. This angle right here is 63.3 degrees. We first had to find this angle. We did that with tangent. And then we knew this was a right triangle, or right angle right there, so this right here had to be the leftovers. Finally, the grade of a road indicates how steep it is. So sometimes you'll be driving along a mountain, and you'll see a sign posted that says grade 3% or something. That is showing how far up you go if you go forward 100 feet. So here's the example I wrote here. If a road has a grade of 15%, that means for every 100 feet you travel forward, you're traveling up 15 feet. Now I believe that's very steep. Let's find out. We want to find this angle right here. I'm again going to call it A. this is again going to be tangent. The tangent of A is opposite over adjacent. So that means that A is going to be the tangent inverse of 15 over 100, or 0.15. That's 15%, 0.15. I just did tangent, not inverse tangent. The inverse tangent of 0.15 was 8.53 degrees. This right here is 8.53 degrees. I still think that's pretty steep. I don't think you drive up roads much steeper than that too often, but no, I'm definitely wrong about that. Okay, we use tangent a lot. Tangent is basically ends up being slope. It ends up being slope because it's opposite over adjacent, and opposite over adjacent is typically going to be rise over run. You know, here's the rise, here's the run. It's rise over run because if you have things oriented by being horizontal, like we think about what's the run from the run on horizontal, here's the rise. So tangent usually gives you slope. Okay, that's it for today. Sine, cosine, and tangent are the methods of finding ratios of side lengths if you're given an angle. If you're given an angle, you use regular SOHCAHTOA. Inverse sine, inverse cosine, and inverse tangent are the methods of finding angles given side lengths. If you're given angles and want to find side lengths, use the inverse one, also known as arc sine, arc cosine, and arc tangent. Tangent is essentially the same as slope because opposite over adjacent will frequently mean rise over run. Next video, we'll do elevation and depression, angles of elevation and depression, as well as the law of sines. Angle of elevation just means from horizontal, you're looking up. Angle of depression means from horizontal, you're looking down. It's pretty straightforward. Peace out.